Hey, a quick message for those of you who are listening to this episode on Spotify. I have a small favor to ask. Spotify now allows mobile users to rate podcasts. I would really appreciate it if you can take a quick pause to go to the Techly Journal podcast page and leave your favorite show, your best rating on Spotify. It will help me a lot to get this podcast to reach more people on the platform. Thanks a lot. Let's start first with the fundamentals of software architecture. To many people, actually, when they hear about architecture, some might have different interpretation or definition. But in your view, having written this book, what is actually a software architecture?
Well, we specifically declined to try to define it in our book, just like Martin Fowler declined to try to define it definitively in his very famous white paper called Who Needs an Architect? Actually, Mark and I and another author, Raju Gandhi, are currently working on Head First software architecture. And the Head First book series, is almost a graphic novel. And we are actually wrestling much more directly with the how do you define architecture and what is the line between architecture and design. In that book, we sort of usefully dodged it in the fundamentals book because it's such a tricky thing to try to define because it's so many things and a single definition has a hard time capturing all of the facets and all the nuance. But here's our most recent stab at it. We can't define software architecture, but we can define a software architecture decision. And a software architecture decision is one where all of the possibilities have serious trade-offs associated with them. Because the real essence of software architecture is trade-off analysis. For easy questions, they're easy and you can answer them. But what we bump into more often are things that don't have easy answers. And there is no best solution here. So now you've got to find what the least worst combination of these forces are. That's one of the things that Mark and I talk about is trying to find the least worst solution, not the best solution, because very often they're just fundamental things that are in conflict with each other. And you always have to compromise and always have to do trade-offs. And so I think that's the essence of software architecture. It really gets to the common definitions of stuff that's hard to change later. Well, why is it hard to change later? Because there's significant trade-offs associated with that decision, which means that you trade off some capabilities for other capabilities, which is the essence of a kind of a software architecture decision. Ralph Johnson's famous definition is it's the important stuff, whatever that is. But again, it's important because it has serious trade-off implications. We view architecture and design not as a binary, but a spectrum. You can kind of see on the spectrum where you are. So one far end is something like the color choice, the user interface element, which is trivial to change. It's literally less than a second change to make that design change versus changing from a monolith to microservices, which is a month or year-long effort. That's kind of the opposite ends of the spectrum. And then everything else is sort of in the messy gray middle area between architecture and design. But I think it's important to note that regardless of how much it is an architecture decision, there should be collaboration between the developers and the DBAs and the database folks and the people who actually build the software system, because none of these roles can be successful in a vacuum. But at the same token, there are some decisions that require more thought and more trade-off analysis and more responsibility. That's part of what makes the role of software architect difficult, is because it is the nexus of so many responsibilities and questions that need to be answered, because the software architect can see process issues and opportunities and engineering opportunities and issues and DevOps. They touch so many things and have such a unique perspective that adds to the weight of many of their decisions, because they're the only ones that are really have enough perspective to make a lot of these decisions.
So you mentioned a couple of times already, like architecture and design, or maybe some people call it system design. Are they the same? That's the first thing.
As far as I know, there's no standard definition of system design, which is the problem with architecture design and all these things. I mean, design is a facet of architecture, because to do architecture, you have to design things. But design is way too broad a word as well, because, I mean, anything that's created by a human is design. We're running into the limitations of language here, trying to define something that is so multifaceted, because software architecture is about designing the structure of the system, the components and relationships, and defining the architecture characteristics. But it's also about leadership. It's about merging technology decisions with business decisions. How do I take a business case and reify that in technology? How do I make current technology work on the given constraints that I have? physical constraints versus cloud computing versus where the resources go. They're often the tech lead as well. So, how do I manage conflicts in the team? One of the common things you learn, particularly if you're an architect at ThoughtWorks, is dealing with strong personalities with very strongly expressed differing opinions about technology directions you should have on your project. That's leadership and negotiation more than it is about technology choices. So, I mean, all these things make up the role of software architect. And I've only scratched the surface of the things that you run into in a lot of organizations that fall into the heading of software architect. So, I think you've never seen a good, concise definition because it's impossible to have a, it's like, give me a good, concise definition of art. Some things just defy simple definitions, and software architecture seems to be one of those things.
So thanks for putting the emphasis on soft skills and leadership as well, because that is part of the architecture job, right? To influence people, to explain the rationale so that the business also understands why certain things are difficult, why there's a trade-off. Speaking about trade-off, right? You have these laws of software architecture. There are two laws. If you can maybe briefly describe them, and why do you come up with this law?
So, one of the things that Mark and I wanted to do as we were working on the fundamentals book, it's worth mentioning too, and this may be of some interest to your listeners, that what Mark and I have figured out how to do is to iteratively design books. So, you're from ThoughtWorks, you're familiar with iterative software development. Most people think that books are these giant waterfall projects where you have to go to a dimly lit room and think deeply for months and years at a time and write all this stuff down and finally release this huge thing, this massive release. What Mark and I realized is that you need feedback, and that makes material better. When we started teaching a fundamentals class, we started this feedback loop, and we made a commitment that every time we teach this class, we're going to make one substantive improvement to it. So the next time we teach it, it'll be one iteration better. We did that for several years, and we realized, hey, we've refined this material enough that we could actually write it down in a book. And that's exactly what we did. But one of the things that we were trying to do in that book as we were going through that iterative process is, okay, let's keep an eye out for things that seem universally true, things that we can't find an exception to anywhere. And we started with a handful of them and ended up with just two that survived that process. And those are these two laws that we codified. We actually wanted more of them because it's cooler if you have 10 laws, but we ended up just with two that seemed to work as holistically as these did. The first one is that everything in software architecture is a trade-off. That is kind of the defining characteristic of software, is that it involves a trade-off of one kind or another. And we built a corollary to that law that if you think you found something that doesn't have trade-offs, it probably just means you haven't figured out what those trade-offs are yet. This is sort of an homage to the very famous Donald Knuth quote about premature optimization in particular. His quote was, rules for optimization, rule number one is don't do it. And rule number two is don't do it yet. So that's sort of that corollary we have. And then the second law that we codified was that the why is more important than the how. And the way we got to that was one of the things that we wanted to do as we were teaching this material is make it hands-on. We borrowed this idea of an architecture kata, which is a little time-boxed exercise that forces an architect to go through trade-off analysis and figure out where components live and that kind of stuff. We were having people do that live, and they were drawing these pictures on flip charts and sticky notes, etc. Mark and I, because we were teaching this at conferences, Mark was actually teaching this live quite a bit. We thought, oh, well, it'd be really cool if we built up a library of these solutions to these kata problems, and we started snapping pictures of all these solutions. And after we'd done that for a few classes, we realized that they were pretty much useless because you could see how a particular team had solved that problem, but you didn't know why they chose this trade-off versus this one. And we didn't force the teams to write any kind of ADR or justification because it was a 3-day exercise. You don't have time to do that. And we realized that how something works is okay, but why it works is so much more important. And that's true as an architect. When you come upon an existing system that you don't have any background on, I can explain exactly how this architecture works, how messaging works, how dependencies work, and analyze all the technical bits and bobs of the architecture. But there are going to be some things that's like, I don't know why they chose this trade-off versus this other one because I might have chosen a different path. That is the essence of what's interesting in architecture is the rationale and the reason why you did something, which is one of the reasons we stress this idea of creating lightweight documentation to capture that why of when you do make these important decisions. So that reasoning that you went through doesn't just entropy into the universe.
It's very interesting that when you mention about these architectural kata and patterns that work for people, but actually they become useless, right? Because yeah, I also learned that architecture is all about context. So when you mentioned these two laws, right? Let me repeat one more time. The first law is everything in software architecture is a trade-off. And then the second law is why is more important than how. So yeah, we can all explain about a certain architecture, how things work, the structure of the code and things like that. But why certain things are built that way, I think is also something that is important to capture, maybe in the architectural decision records or maybe some kind of other format. Let's try to move on to the second part of the conversation, which is about your second book, Software Architecture, the Hard Parts. We covered it in the beginning where people refer software architecture as things that don't change so often, very hard to change, and also things that are important. What is the rationale of you writing this second book, The Hard Parts, and what do you mean by the hard parts?
Well, the way that book came about was as we were writing the fundamentals book, we kept bumping into these and we started digging into explaining some problems. We realized, wow, this is way too complicated for a fundamentals book because we're getting way into the weeds. And so we took all those problems and set them aside and said, okay, we'll deal with those later. Over time, this pile got bigger and bigger. And by the time we finished the fundamentals book, we had this giant pile of difficult problems that we had kind of set aside. At one point, Mark actually, we were in conversation, sort of made a joking comment of, well, our next book should be called Architecture, the Hard Parts, and we should just cover all those things. And then we said, well, actually, that's a pretty good idea because what it forced us to do was look at that giant pile of problems and figure out why are you so difficult? We basically applied our second law. What's making these set of problems so difficult? And that was really the basis for software architecture, the hard parts is an analysis. And of course, the short answer to that question of what was making them so difficult is that all of them really required this kind of continual trade-off analysis. Mark got in trouble a few years ago at a conference for saying that there are no best practices in software architecture. And he softened that a little bit to say that in structural design, there are no best practices because when you think of the concept of a best practice, which is sort of out of fashion right now, but the whole concept of best practice is literally that when this situation comes up, I can just turn my brain off and do this thing because it's the best practice. It brooks no compromise. If they'd called it a better practice, then at least you'd have some wiggle room. But no, it's the best practice. And so turn your brain off and just always do this. But so many of these things in software architecture, you can never codify a generic rule like that. A great example of this is I have this shared functionality in microservices. Should I couple to it between two services or should I duplicate it? Both options suck. But you can't say you should universally do one or the other because every time you run into that situation, you have to look at, okay, what is it going to do? What are the pluses and minuses on either side because of the domain behavior or the architecture characteristics or the load? All of these different facets go into that decision every time. And that's what makes a lot of these problems in architecture so difficult is you cannot codify always do this in this situation. You have to do this trade-off analysis. So the entire second book, the examples are really about coupling in distributed architectures. And the whole first half is about static coupling, which is how things are wired together. And the whole second half is about dynamic coupling, which is about how things call one another. I actually realized yesterday, and would have put this in the book, the static coupling is kind of the three-dimensional view of the world because it doesn't change. It's all the dependencies and how things are wired together. Whereas the dynamic coupling is the fourth dimension because it happens in time, because things are calling each other in request response cycles and that kind of stuff. The book is driven by those examples, but what we're really doing in the book is codified in the subtitle, which is Modern Trade-off Analysis for Distributed Architectures. We're showing architects how to do their own trade-off analysis because that's what you have to do. There are no best practices in this world. So there's a little bit of a rhetorical trick in our book. The first 14 chapters are all written in first or third person. But the last chapter is called Build Your Own Trade-off Analysis. And it's written in second person because it is the call to action to the readers that, hey, we've shown you now 14 chapters of examples of how to do trade-off analysis. Here is the list of all the tools we use to do that codified, because what we're really doing is encouraging architects to build their own toolbox of trade-off techniques. Because one of the things that we also say is it does you no good as an architect to get good at generic architecture, because there is no such thing as a generic architecture. You said it before, it's all about the context. What your job is to get really good at doing trade-off analysis in your architecture. So what you need is a toolbox of trade-off tools that you can use. And so we give you some generic ones, but we encourage you to build your own toolkit. And so we show you how to use some of the things that we did to start building up your own toolkit. So the fundamentals book was really about this kind of broad overview of software architecture. The hard parts book is very much focused on how do you do trade-off analysis in modern architectures.
Yeah, I find that one of the rarest skill in a good architect is to do this kind of a trade-off analysis that works in the context of the teams they're working, the systems that they're working. I think you mentioned a couple of times there are no best practices. Also in the book, you mentioned the seminal paper or book written by Fred Brooks, No Silver Bullet. So this is something that I always refer when people are talking about architecture. So I think thanks for the plug. People these days, we all love to chase the hype-driven development, be it whatever cloud, containers, Kubernetes, and all these best practices that we think will solve all the problems. But I find that over the time, things tend to change. One thing that is good at this time, maybe at certain times or certain contexts, is not good. Thanks for having a reminder that in architecture, everything is a trade-off. There is no best practice. I hope you enjoyed this short clip from TechLead Journal Favorite Playlist. If you find this episode useful, please help share it with your friends and colleagues who you think would also benefit from listening to this episode. And if you want to listen more from this conversation, please go back and listen to the original full conversation with my guest. Stay tuned for the next TechLead Journal episode, and until then, goodbye.